I'm Anil Kumar sharing with you a question from my subscriber, and I hope the solution will help many others. The question here is the position vectors of point A and B are 3i plus 5j plus 7k and I plus 9j plus 9k respectively. Given that the position vector of C is 4i plus 6j plus 7k, show that C does not lie on the line containing A and B. Find the position vector of foot of perpendicular from C to the line AB, and hence show that the length of the perpendicular from C to AB is square root of 11 over 6. So we are given points A and B. So point A is given to us as 3i plus 5j plus 7k, and B is given as I plus 9j plus 9k. Now, to show that C does not lie on the line AB, what we can do is we can find direction vector for AB, right? So let's find the direction vector AB. So that will be 3i minus I. So what we can do is, let's write, okay, 3i minus I, 5j minus 9j, 7k minus 9k, right? Now I, j, k's are unit vectors in the direction of x, y, z. So sometimes we write them like this, most of the time, right? However, in my video, I'll avoid. Okay. So this vector is 3 minus 2 is 2i, 5, this gives me minus 4j, and that gives me minus 2k, right? Now the vectors could actually be also written as, we can just take 2 common, right? We could take 2 common and write it in the form as, let me write down here. So we can write this vector DAB as, if I take 2 common, so I get I minus 2j minus k, right? Okay. We could also write these directions as in the form 1 minus 2 minus 1. Is it okay? So I'll use that form of writing the direction vectors from now onwards. Correct? We could write equation of this line in vector form as r equals to any given point. First point, for example, we could take as 3, 5, 7, right? Plus t times the direction vector 1 minus 2 minus 1. Okay. Anyway, so what we have found here is the direction vector for AB, which is 1 minus 2 minus 1. Now, let us find direction vector for BC, for example. And if these direction vectors are same, then we'll go further to show that C lies on the line. But if the direction vectors are different, then C does not lie on line AB, correct? So what is the direction vector for, let us say, BC? So line B is I, 9j, 9k, and C is 4i, 6j, 7k, right? So if I take this, now I'll use the matrix form, 4 minus 1, let's write 4 minus 1, and then we have 6 minus 9, 6 minus 9, 7 minus 9, 7 minus 9, and that gives us 3, and that is minus 3 and minus 2. As you can see, these two directions are not matching, right? So DAB is not equal to, or not even a scalar multiple of DBC, right? That clearly indicates that C is the position vector C is not on the line AB, right? So that means we have a line AB kind of, let's say, like this. and point C is somewhere away. Let's assume this to be somewhere away like this. Correct. So we have shown first part, which is that C is not on the line. Now second part is find the position vector of foot of the perpendicular from C to AB, and hence show that the length of perpendicular from C to AB is that. So now we'll try to figure out what is the foot of this perpendicular and how much is this length, right? So let this be at point D. So now we'll do that. So let's continue on the next page to find the foot of the perpendicular and the shortest distance. So what I've done here is written the position vectors for A and B and C, and we already know that the direction for AB is that's right, 1 minus 3 as minus 2, 9 minus 5 as 4, 9 minus 3 as 2, which is same as also we can just factor out minus 2, which we did last time. So it is 1 minus 2 minus 1, correct? So that is the direction AB, correct? Now what we need to find is let's resketch. Let's say that's the line AB for us. And we have a point C somewhere away. So what we need to do is we have to find the shortest distance between C to the given line AB. And that is possible if we could find foot of the perpendicular D, right? So that is the objective in this particular exercise. So to find this point, let's take a general point on the line AB. So AB could be written as now equation of the line AB. Let me write down the equation of the line AB here, or let me write down here. We'll write down here. So or we are writing the equation of line AB. So we are talking about line AB. AB is equal to, we could take point A, which is 357 plus T times the direction 1 minus 2 minus 1. So that is in the vector form. So any point, let us say a point D dash is on this line. So what are the coordinates of point D dash? So the x value will be 3 plus t, y value is going to be 5 minus 2t, and z value is going to be 7 minus t. Is it okay? So that becomes the coordinates for point D dash, right? So if I connect D to D dash, let me just do that. This is any general point, so that is general point. If I connect CD, then how can I write CD as? So I could write CD as, so the x values change. 4, C is 4, 6, 7, right? So it is 4 minus 3 plus t. And then we have 6 minus 5 minus 2t and 7 minus t. Is it okay? So that becomes CD, which you could simplify and write as 4 minus this means 1 minus t, 6 minus 5 means 1 plus 2t, 7 minus 7 is 0. You're left with t. So that becomes CD. Now the thing is, if CD has to be perpendicular to AB, so if CD is perpendicular to AB, let's write down here. So I'm actually dividing the page in two portions to explain the whole concept. So here we found the coordinates of point D dash, right? Now, if CD dash is perpendicular to line AB, then this direction of CD, which we have, right? This is actually the direction CD, correct? So this direction of CD dot the direction of AB should be equal to 0. Is it okay? For them to be perpendicular, correct? So let's do that now. So the direction of AB is right there, and CD is this. So what we will do now here is that the direction CD dot direction AB should be equal to 0. Is it okay? So CD is 1 minus t, 1 plus 2t, t dot AB is 1 minus 2 minus 1. Is it okay? So that is what it is. So let's multiply this. I mean dot product. Okay. So 1 times we get 1 minus t, minus 2 times gives us minus 2 minus 4t, minus 1 times t gives minus t, and that is equal to, all this should be equal to 0. Is it okay? So what do we have here? 1 minus 2 is minus 1, and minus t minus 4 means minus 5, and this is minus 6. So we have minus 6t. Correct? Now that should be equal to 0. That means 6t equals to minus 1, and it implies t is equals to minus 1 over 6. Correct? So t is minus 1 over 6. Do you see that? Since we now know that t is minus 1 over 6, we can find the coordinates of point D. So this is the condition that the line is perpendicular. Do you get the idea? Correct? T is minus 1 over 6. So we'll substitute this value here and find the x value as equal to 3 minus 1 over 6, correct? 1 over 6. The y value will be 5 minus 2 over 6. Minus minus makes it plus, so 5 plus 2 over 6. And the z value will be 7 minus minus becomes plus 1 over 6. Do you get that? So we get the coordinates of point D, which is this. Since t is equals to minus 1 over 6. Is it okay? So let me rewrite here the coordinates of point D, which we have found. So coordinates of D are, I'm not calculating this, we'll do it with calculator later. Okay. 5 plus 2 over 6, and z is 7 plus 1 over 6. Is it okay? So these are the coordinates of point D for us. You can always simplify. And now in the next page, we'll find the shortest distance. That is the distance between C and D. Now let's do the final part. We, in this question, are working with points A, B, and C. We already found the point D, which is the foot of the perpendicular. And in this part, we'll show that the length of the perpendicular from C to AB is square root 11 over 6, right? So what we just found was that if there is a line AB, let's say this is A and this is B, then we know there's a point C here, which is not on the line, and we also found the point D, foot of the perpendicular. Coordinates of point D, which we just found, are, let me write down the coordinates of point D now. Coordinates of point D, we didn't simplify, we wrote as 3 minus 1 over 6, 5 plus 2 over 6, and we wrote 7 plus 1 over 6, correct? Now let's simplify this. We can take 6 as a common denominator. So 6 times 3 is 18. 18 minus 1 is 17 over 6. You can use calculator. 6 times 5 is 30. 30 plus 2 is 32 over 6. 6 times 7 is 42 plus 1, 43 over 6, correct? So that is the foot of the perpendicular. Now we need to find distance CD. Is it okay? So we have to find this distance CD. We'll use the standard formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square root. Coordinates for point C are already given to us. These are the coordinates. Let me write them as 4, 6 and 7, correct? So the distance will be square root of 4 minus 17 over 6 whole square plus 6 minus 32 over 6 whole square plus 7 minus 43 over 6 whole square root. So let's use the calculator to calculate the answer. It is square root within brackets 4 minus 17 over 6 whole square plus 6 minus 32 divided by 6 whole square plus within brackets 7 minus 43 divided by 6 whole square, and that is equal to, it gives it equal to square root of 66 divided by 6. Right? We are looking for square root of 11 over 6, right? It is actually the same answer. You could write this as, let's see how we get the same answer, right? We could write 6 within the square root, then this could be written as 66 over 36, correct? Square of 66 goes in. Square of 6 is 36. You know, square root of 36 is 6, so it's the same, right? You could simplify this, dividing both by 6, you get 11 over 6, right? Which is what we have here. So that is how you could actually, dividing both by 6, we get that answer. So that is how you could actually find or prove that the distance between them is square root 11 over 6. I hope that helps. So go through this video once again, try to understand the concept. If there are any questions, feel free to post them. And if you like, that's great. Thanks and all the best.